In this next video, we're going to look at problem solving processes and techniques. Okay, so how do we go about solving problems? Well, first of all, understand the problem. To understand the problem, you're going to have to read it. If you read it once and you don't understand it, read it again. If you still don't understand it, read it out loud, okay? Make sure you understand what the problem is saying. Rephrase the problem. Tell somebody else what the problem says. You have to understand the problem. And then, once you understand the problem, you need to identify key information. Just like I already mentioned, identify that key information. Ask yourself, how is it interacting, if you can see that. The next step is to develop a plan. When you identify your key information, you can underline it, you can highlight it. There's a lot of different ways you can approach that identification process. Develop a plan. Okay, now, there's a lot of different plans you can follow. You can look for patterns, which we've already done. You can solve simpler problems, and we'll do some of that. To be able then to apply what you learn to a more complex problem, you can work backwards. I don't usually use that one, but I know some people who do. If they know the answer, they work back from the answer to figure it out. Draw pictures. You will see me draw a lot of pictures because it helps me organize my thoughts if I draw a picture. Okay? You can guess and check. You can take a guess at the answer and then check to see if it's true. Okay? You can just use reasoning and logic. And you can use formulas. And we will do some of all of these maybe not all, but a lot of these various approaches we will use as we work with problem solving. After you have decided on your plan, then carry out the plan. In other words, do your plan. And then ask yourself, question, answer. Did you answer the question? If it isn't answered, it means you're not finished. And then lastly, check if the answer is logical. I use that one a lot. I will look at an answer and go, that answer doesn't look like it makes any sense. And then that tells me that I have made a mistake somewhere. Okay? Now let's look at a kind of a complex problem, okay? A thief stole some apples. As he was leaving the orchard, there were 3 watchmen. When he encountered the first watchman, he gave that watchman 1/2 of the apples he stole, plus 2 more. Then he encountered the second watchman. He again gave that thief 1/2 of the apples that were left, and 2 more. And then the third watchman did the same thing. 1/2 of the apples he stole and 2 more. When he was finished, the thief had 1 apple. How many apples did the thief steal? Okay, how many apples did the thief steal? So that's where we're going to start from. Okay? So let's look at this. What would be a good approach to solve this problem? Well, I think a chart would be a really good idea. That's a plan that we're going to use, and we're going to look at what happens when we do this chart. I think we're going to have to get another marker pen. Yes. Okay. My thief, when he was done, had 1 apple. Okay? First, second, no, we're going to start with the third one. We're going to go backwards. Third, second, first, and what did he start with? Okay, so let's look. The thief ended up with 1 apple. When he encountered the third watchman, what happened? Well, what did he have when he came to the third one? Well, 1 plus 2, multiply that by 2. Because remember, what did he do? 1/2 of the apples and 2 more. And that left him with 1. So we could look at that as 1/2 x plus 2 equals 1. So if I subtract my 2, and we'll learn to do this, you've learned it. So I have 1/2 x equals 3 multiplied by 2 to get rid of it, and I end up with x is equal to 6, right? So 1 plus 2 times 2 gives me 6. So he had 6 apples at this point when he came to the third thief. Now, what's going to happen here? Well, again, 6 plus 2 more, and double it. And that gives me 8 times 2, which is 16 apples. And then 16 plus 2 times 2, that gives you 18 plus times 2 is 36 apples. So what did the thief start with? He started with 36 apples. So there's a logical approach to take to get this. Now, we could check it by doing this. 1/2 of 36 is 18, minus 2 more leaves him with 16. 1/2 of 16 is 8, minus 2 more leaves him 6. 1/2 of 6 is 3, minus 2 more leaves 1. So we can check and see if our answer really does make sense. So how many apples did the thief start with? He started with 36 apples. Okay, let's look at another one. There's all kinds of fun problems you can do with these kind of approaches. And some are easier than others, some are harder than others. I think that apple one is one of the harder ones, okay? So this one, we're given some circles here. Okay? We have the numbers 1 through 6, and we have to place those numbers inside those circles in such a way that this line is going to give a sum of 12. this line gives a sum of 12, and this line gives a sum of 12. So we have to come up with 3 different ways to make 12, is what we're looking at, using all of these 6 numbers, because we have 6 circles. So what I do with this is I start, first of all, with looking at different ways to make 12. Well, let's see, 6 plus 5 plus 1 makes 12. 6 plus 4 plus 2 makes 12. So there's 2 different ways to make 12. Now I need one more. How about 5 plus 4 plus 3? 9 plus 3 is 12. So there's 3 different ways to make 12. You see that? That equals 12. That equals 12. And this one equals 12. 3 different ways to make 12. Notice too that every one of these circles is used twice because it's in this line, but it's in this line as well. So we're going to look for the numbers that are used twice. So 6 is used twice, 5 is used twice, and 4 is used twice. So that means 6, 5, and 4 are the numbers that have to go in those places that are used twice. A 1, 2, and 3 is what's left. So 6, 5, 1, 6, 4, so this one has to be 2, and 5, 4, this one has to be 3. So there's a logical approach to do these kinds of problems. Okay, let's look at another one. How about this one? The sum of the first 1,000 numbers. And that means we start with the number 1, okay? Well, that's an awful lot of work to write all those numbers down and add them all up. So let's look and see if we can do a simpler kind of amount of numbers, add them up and see if we see a pattern to this, okay? So let's look at this. Let's do the first 10. 1, 2, 3, 4. Let's put a plus in between each one of them. If I add up all those numbers, the sum happens to be 55. One thing I notice about 55 is that 55 is actually 5 times 11. Those are the only 2 factors of 55. 5 times 11. 5 is half of 10. And 10 was the amount of numbers I started with. So it appears like 10 divided by 2 is equal to my 5. Also, when I look at 11, I notice that if I add the first and the last number, the sum is 11. 2 plus 9 is 11. 3 plus 8 is 11, and so on. So I notice that 11 is the sum of first and last numbers. Okay? 10 is the number of numbers I used. So it appears like we can use this pattern that we have here, and if we take the number of numbers divided by 2, multiply that times the first number plus the last number, we will get the answer. Okay, you see how we did a simpler one and saw the pattern, and now we're going to apply the pattern to this one. So first and last number here would be 1 plus 1,000, and 1,000 divided by 2. So this is 500 times 1,001, which is equal to 500,500, which is correct. So you can see how you can use that pattern to help you figure it out. Let's look at another one. We got several other kinds that we can use. Lots of nice patterns we can look at. Lots of nice problems that are interesting to look at. An uncle gave a nephew or a niece, I'll just say me, $1 the day I was born. On every birthday after that, he doubled it. So at the end of 1 year, on your first year birthday, you got $2. On the second year birthday, you got $4. Third year birthday, you got $8. Fourth year birthday, you got $16. So what's happening here? The sequence is, it's a geometric. You are multiplying by 2. Okay? So it doubles the previous term is the pattern that's happening. But we need something that's going to make it easy, because we want to know how much would you get on your 18th birthday. Well, 2 is the common difference, not the common difference, but the common ratio. And so the whatever term we're looking for, a sub n, is going to equal my 2 to my nth power. And n is the year that the birthday is. Okay? So the 18th birthday will be 2 to the 18th power, which is equal to, it's a really big number, 262,144. That's a lot of money. That's not even the sum of all those years. It's just that specific year. Okay, let's look at one where we draw a diagram. Okay, this problem says there's 5 teams in the league, and each team plays every other team in the league 4 times. Okay, so how many games is it necessary to play to be able to have that happen? Well, some people say, well, how about 20, 5 times 4? Is that right? We'll see if that's correct. So let's look at what this might be. So let's start. We've got the Raiders. And Jackals. Blazers. Warriors. And our last team is the Eagles. Okay, remember, they're going to play each one 4 times. So if I have the Raiders playing the Jackals, this is actually going to happen 4 times. Okay? So we want to know how many arrows, or how many times, how many games total it's going to take. Okay? Well, Jackals and Raiders, Raiders and Blazers, Raiders and Warriors, and Raiders and Eagles. Well, that's 4 times 4, that's 16 already. But Jackals are going to have to do Jackals and Eagles, Jackals and Warriors, and Jackals and Blazers. So that's another 1, 2, 3. So we have 4 arrows plus 3 arrows. Okay, now the Blazers, we've already got the first 2 drawn, but the Blazers are going to do the Eagles and then the Warriors. So that's going to give us 2 more. And the Warriors have already done this one, and this one, but they haven't done the Eagles yet. So that's 1. So a total of 10 arrows. But remember, every arrow represents 4 games. So 10 times 4 equals 40 games. So this league is going to have to play 40 games during the season for those conditions to be met. So you see there's a lot to that as you figure it out. Okay, here's another one. Even if you don't run into all these examples in this one, you'll run into them somewhere along the way, okay? So, I have 50 cents. I have quarters, dimes, and nickels. How many ways can I make 50 cents with those particular amounts? This one is easier to do with a chart. These are quarters, these are dimes, these are nickels, and this is my 50 cents, my total, and I want it to be 50 cents, okay? So I can make 50 cents with 2 quarters, no dimes and no nickels, that makes 50 cents. I can do 1 quarter, 1 dime, well, let's do the most. 1 quarter, 2 dimes, and 1 nickel also makes 50 cents. 1 quarter, 1 dime, and 3 nickels makes 50 cents. 1 quarter, that's it. 0 dimes and 5 nickels makes 50 cents. Okay, all the rest of them will have 0 quarters. There won't be any more quarters. We can have 5 dimes and 0 nickels makes 50 cents. 4 dimes and 2 nickels is 50 cents. 3 dimes and 4 nickels makes 50 cents. 2 dimes and 6 nickels makes 50 cents. 1 dime and 8 nickels makes 50 cents. 0 dimes and 10 nickels makes 50 cents. So how many different ways can we make 50 cents? 2, 4, 6, 8, 10. 10 different ways you can make 50 cents. That's why I said a chart is easier on this one. Okay, another way we can do this is use a variable. And these are used frequently when you read something and you translate it like we did. We have done some of this already. Okay? So let's look at this. A number multiplied by 8 and plus the product, and the product is added to 6. And the product is added to 6. Okay. A number, that refers to a variable, and we're going to let that number equal x. So a number is going to be a variable x. All right? So a number equal to x, multiplied by 8. So that means this number here is going to multiply by 8. So it's going to be 8x. And the product refers to my 8x is added to 6. Okay? And then it says, if the sum is 30, if the sum is 30, what is the number? Okay, so if the sum is 30, that means equals 30. What is the number? Okay, so now we're going to solve. First of all, subtract your 6 from both sides. You get 8x is equal to 24. And then divide by your 8 to undo your multiplication. And that means x equals 3. So your number is 3. So you can see there's a lot of different ways to solve these problems. And so that is the second part of your homework assignment. And that is found on page 22. And every problem will be distinctly different, so you just have to read every single problem. And it's 2, 3, and I don't remember the rest of the numbers, but you have your homework assignment on the blackboard. So have fun.